Hey everyone, today we'll be building another OKR-T30 Passthrough mod. This is an updated video, so I do have an older video where we built an OKR-T30, but a lot of things have changed and improved since then, so I figured it was time for an update on that. Things that have changed, number one, the enclosure. I now have CNC machined pass-through enclosures. If you're making just one for yourself, maybe it's not that bad, but it's very time consuming to, especially anything that's not a circular cutout. It was very time consuming, especially if you get an order for like 12 of these. I would spend a good part of 2 days prepping enclosures, grinding the lean off the Hammond enclosures, doing the rectangular cutouts, powder coating, and so on. So new CNC milled enclosures already have all the cutouts required, available anodized black or silver, or unfinished, which can be powder coated. And although it's an OKR-T30 today, the enclosures are also available with the DNA 250 cutouts, or the old school, the 250C cutouts, or the old 250. Those are also an option. They have a recessed 510. Very nice. Other new things for which we'll see in the video, but to wire the OKR-T30, if you watch the first video, these pins are real close together, and sometimes there's multiple things connecting to the same pin and so on. So have a new breakout board for the OKR chip. All the external components, again from the last video, those two capacitors, the pull down resistor, the other resistor for the to kind of floor the trim resistor, all on the board now, surface mount on the board. So the OKR slides in, gets soldered on, and then you just need to wire your 510 negative, your 510 out, your fire button, the optional voltmeter over to the trim resistor, and the power in positive and ground. So these make wiring the OKR a whole lot easier. Other new thing, the cables. There was something else that was really time consuming. Again, if you watch the old video, I would take 4 lengths of wire and then that expandable nylon sleeve and make the cables myself. Again, if you're making 1 or 2 for yourself, no big deal, but you get an order for 12 of these, there's a whole day gone to making the cables. So now we have these pre-made cables with a GX16 permanently like heat crimped on one end, because it's always what I use on the mod side. On the other end of this, depending on the type of connector you're going to use on the vape station, if it's a GX16, you can wire that on, or speak on, but you get to choose the connector on this side. They're 6 feet in length, so the max is 6 feet. You want shorter, you cut it to length, solder on the connector that matches your power supply, and you're good to go. Big time savings on the cables as well. So stick around, and we're going to build the updated OKR-T30 pass-through. The first thing we'll do is drill the hole for the GX16 connector on the bottom. Reason I didn't have the enclosures pre-cut with that hole is I usually put it on the bottom, but maybe someone would want to put it on the side here instead. So that hole needs to be drilled. You can place it where you want. I usually go on the bottom. So I'll do that off camera and I'll be right back. So we're done with that hole, and I do it off camera not to have to move my whole camera setup around, but the way I make the hole, first I have a 3D printed drill template, which gives me with a 1/16 drill bit and a pilot hole right in the center. Then I use a combination of stepper bits, these metric stepper bits that I have. This one goes up to 12 millimeters. I also use this one for the 12 millimeter fire buttons. And this one starts at 12. The hole needs to be 16 millimeter. So this one has a setting for 16. So that's how I make the hole on the bottom of the pass-through enclosure. Next thing we'll do is epoxy the few components that need to go in there. So the trim resistor and the voltmeter. Before we epoxy the trim resistor, we'll wire it up here. You need to take the wiper, which is the longest lead in the middle, and you bend it over towards the 0 side. So I just bend so they intersect. And I'll just hit that intersection with a bit of solder. And then I'll trim all the excess off. Now the voltmeter, I usually trim off these little tabs on the side. And then I peel off this protective tape here. Inspect your voltmeter if you're having a hard time getting it into the holes. Sometimes there's glue on the very edge. This one looks fine, I guess, in the manufacturing process. If that's the case, you can carefully with a utility knife scrape it off. It'll snap off if you get the tip of the blade under there. Also, if you go with the powder coat finish on the enclosure, that does add a little bit of thickness. I mean, something negligible like maybe a 0.1 millimeter, but still that does make the voltmeter a little more snug. If you have to, sometimes the corners are as sharp as they can be, but a perfect 90-degree corner is impossible because the tool is round. So if you go with the powder coat, you're having a real hard time getting it in there, you can lightly file down and not a lot, maybe a couple passes on the corners all the way around the voltmeter, and that can help too. I also try to, because the protective film is off here, if the voltmeter would be perfectly flush or stick out and then the mod gets put down, that'll the black on the voltmeter will quickly wear off. So I try and get it like 0.5 mil to 1 mil below the actual front of the enclosure. This way, if the mod is laid down, nothing's touching the voltmeter. Now to help hold all of this into place, I'm going to throw a piece of tape over that. So the components are stuck onto the tape. And now it's easy to either make it flush like I want with the trim resistor, and to get it a bit lower like I want with the voltmeter. Another thing we'll ready before we mix up our epoxy is the board holder. So that'll get, the board holder itself will get epoxy to the bottom. To make sure we get our distances right, I'll temporarily mount the board onto the holder. So that'll go in there. Typically try to center it against the right side and centered up and down. Let's mix up some epoxy. All right, we'll let that cure, and while we're waiting on that, we'll wire up another board with the surface mount components and the actual OKR chip. I mentioned at the start of the video the new Breakout boards for the OKR chips, which makes wiring the whole thing so much easier. If you saw the first video where we made an OKR-T30 pass-through, you need to solder multiple things to some of these pins, and it's a difficult thing to do. But with the Breakout board, all the internal connections that need to be made and all the other components, the resistor, the caps, they're all on the board, and then the only thing left to wire is your 510 out, your power in, the trim resistor, the voltmeter, and the fire button. But we need to solder some surface mount components on here, and they are small. This is a 1206 package. I don't think we could go any smaller, and these be easy to hand solder. There is an option if you order the kit. You'll get the board anyways, but if you want, I think it's an extra $5 if you want me to pre-solder the onboard components onto the board, if you are worried that you may have trouble with that. But let's go ahead. We'll do the caps first. The pads are so small, I can't apply flux with the syringe it comes in, so I just use a scrap piece of wire here, and at the tiniest bit. And I'll do the top cap first. The easiest way I found to do this, I just trimmed my nails too, is to hold it with your thumbnail. And make sure you've got some pad exposed on both sides. So I'll come and tack it right on the top corner here. I don't want to get solder on the bottom part, because then when I place the other cap, there'll be a mound there. So I'm going to try and just tack this top corner. You want to touch the pad and the component. And once one side's done, then you can come and do the other sides without holding it. Second cap on the bottom. Again, holding it with my thumbnail. This time I'll come and tack, well, it's top corner, but I'll drag across to get both done here. Like that, and then I'll drag across the other side to get caps done. Next over here, this is the 1K resistor. Again with my thumbnail. And once one side's in, you don't need to hold it. last surface mount component, the 220 ohm resistor on the other side of the board. And make sure you've got some exposed pad on both sides. I usually hit it a second time just to reflow and make sure the solder goes on the pad onto the component. Good. Now for the actual OKR. I'm turning up my iron as high as it'll go, which in my case is 480 Celsius. Some of these pins here, any pins that are common, for example, these first two, which is the voltage in, are internally connected on the OKR. These last three pins here, which is the positive out, internally connected. These two here, which are the ground. Because of which, if you heat just one of them, the other one's acting like a heat sink, so you need a high heat, and it takes longer before the pin gets hot enough to melt the solder and flow properly on the pad. So in some cases, you might need to touch the iron onto both of them. They'll heat up much faster, and the solder will flow. So that's the plan. Let's give that a try. And you load the tiniest amount onto the tip of your iron. If any of the pins that are common happen to get a solder bridge, which just happened on the ground pins here, you can sometimes, by reflowing and pulling it off, clear that up, but it's no big deal. They're internally connected. So if these first two get soldered together, no problems. The two grounds here, no problem. These last three, that's fine. Now the last ones here are easier. Just turn my iron back down. Again, very small amount loaded on the iron. Good. Check for solder bridges between any pins that aren't common to each other. This looks good. That flux I use is a no clean flux, but it gets sticky, so I'll just swab the whole thing with some alcohol. All right, we'll set this aside and work on the GX16 connector. So I have two versions of these, and these aren't your standard GX16s you get on eBay. These are a much better quality. The threads are machined. They're super clean. So I have the one that I normally use where the nut is on the inside. So if this is on our enclosure like this, nut goes on the inside. And I have another version where nut goes on the outside. Easier to tighten the nut with this version. But I'll use what I normally do, where the nut's on the inside. For the actual power supply for the vape station, I'll often use the outside nut there, the outside nut version. But for the mod, I tend to use the internal nut. So I'll mark, now I always use pins 1 and 2 for the positive. So I usually color the side that is 1 and 2 because the numbers aren't very legible, and it can be hard, especially if this is in the enclosure and you can't see, to figure out what pins are what. So I'll do this first. So I use a 4-pin connector to distribute the load across more than just the 2 pins. Even though we only need a positive and a ground or negative, the pins on these aren't rated for, I think the max rating is 10 amp. So that wouldn't be enough for high powered mods. So by using 4 pins, we're doubling the rating for these connectors. But on the board, there's only 1 hole for positive, 1 hole for negative. So you could wire 4 individual, let's say you can go as high as 18 gauge, and then maybe twist the ends together and put that in the hole and solder it. But instead what I do is I'll jumper the 2 positives. I'll use a piece of 16 gauge, and I'll do the same with the 2 negatives. So I'll have 2 wires coming off of this thing. And to make it easier to jumper that wire, I take a round file, and the 2 reds, and I'll file a groove across these 2 and then again across the other 2. So our wire then will sit in this groove. Do the same for the 2 ground or negative side here. I don't know how well you can see that on camera. Now I'll bear these long enough that they could jumper across both pins. I'll also tin the connector . So I normally like to send my wires, look at where the groove is, and I'll send the wires in that same direction. So the black wire is going to go out this way. If you mount the board pretty much halfway in the enclosure like I did, and then about 1.5 inches length on these wires. So we'll set this aside. All right, we'll pre-wire the 510. A little trick maybe, to not forget to put the little rubber gasket back on. Drop it in your nut. This way, when you put the nut back on, you'll see it if you forgot to put it back before. Again, I'm using the helping hand here, squeezing the connector to push the pin out as far as possible. Again, with these, about 1.5 inches for the positive and 1.75 inches for the negative. Okay, we'll start assembling or wiring the board. To not... Okay, let me get this temporary board out of here. Although the kit will come with some small 24 gauge wire for the fire button and trim, there's actually more than enough extra on the voltmeter here. Normally what I do is I push it down and then I'll measure like a, let's say, finger length more, and I'll cut that, and then there we go. We got 2 pieces for the trim resistor, 2 pieces for the fire button. So I usually start with the 510. So the 510 positive. And our negative. Then I'll do pre-wire the leads for the trim resistor and the fire button. The trim has a plus and minus, so I'll use the black in the minus, red in the plus. Although we have a black and red wire for the fire button, there's no plus minus, so it doesn't matter how you wire that part. Okay, before we put this in the enclosure, let's get our GX16 in there. Now, because of the way I wired the GX16, if you look at the board, the power in is on this side, so the red on this side, the black on this side. Now when my connector's in, I've got the black on that side, the red on that side, so it'll be a nice loop into that hole. Which means I want my groove, again, the way I wired it, to end up, once tightened, to end up pretty much perpendicular to the top of the enclosure here. So I've got it just about as tight as I can go with my hands. So I'll place that mark anyway from around a quarter of the way down, and then as I tighten this, I should pretty much end up here. Now this is kind of a hard part. Holding the nut is easy with some pliers. The outside part though, if you want to get it real tight, don't go squeeze onto this with some pliers. It's relatively soft metal. So what I do, I have a sacrificial male portion here. I don't recommend doing this with your own because this plastic is brittle. It's easy to crush this and ruin the male part of this. If it's the only one you have, don't. If you want, maybe order a second sacrificial one just for this. But so I'll put this in here and then I'll use the vice grips to tighten her up. Even if you don't do this and you get it as tight as you can, holding the nut and with your hands here, that's fine. Either way, I'll drop a few drops of epoxy across the connector, the nut, and the enclosure on both sides here. You'll see at the end, just to make sure that nut never comes loose and this connector doesn't wobble after a while. So tight as you can, and one way or another, we're going to secure the whole assembly here with some epoxy on both sides. If ever you need to take it out, that's fine. You can, the epoxy with the small screwdriver, if you bang at it, it'll crack off. But so that's the plan here. Already there's little pieces of this connector. I've used it several times to tighten a bunch of these down. Okay, I should have trimmed and tinned these first, but let's do all of this now. So the way I do this, we want when the board is in for these to be looped into the holes here. That would be incredibly hard to do with the board in place. In fact, you couldn't get under it to solder. So what I do is stand these up. I'll wire them like this, and then we'll just bend the whole thing down into its final resting place. And now last thing is the voltmeter. and the negatives on that side. So I gave myself enough slack here the way I measured it. Okay, so this bends down. I like to tuck the voltmeter wires along the side. Make sure your trim resistor wires are out the back. You can kind of move these a little bit if you need to. So the board's in. A few other things to solder. We'll do the trim resistor. The length here, there's no way you'll be able to cut and strip if you cut them really short. So I stand them up, fingers width, and then I trim there. And then I know I have enough length to get the strippers in here. So the black wire goes on the bottom, the pins we jumpered earlier. That was already tinned down there, if you remember. So that was easy. Now the top pin for the positive. You can tuck those away. I'll do the fire button last. So let's get our 510 in. I want those crosshairs to be like an X. So tighten as tight as you can, and then you can still rotate the whole assembly. Be careful if you're using a 510 tool. and some pliers up top. If you notice, I'm always on an angle to make sure I'm not scratching up the finish on the enclosure. And for the fire button, I'm going with the very fashionable, the ABM 12mm. You know what? I wonder if a black one might look better on this. So same button, but in black. And to trim the wires for the fire button, same deal. Fingers width as low as you can go. Doesn't matter which side the red and the black goes on for the... All right. Next, we'll throw some epoxy down to make sure this never comes loose. So another small batch of epoxy. So make sure we get some on the connector, on the nut, and on the enclosure. So we'll let that harden. Let's give this thing a whirl. Get the lid on there. and black screws to match the black enclosure. How great does that look? Got the trusty vape station over here. Get a tank on here. It's pretty great. So our final recap, updated video for the OKR-T30 Passthrough. Bunch of new stuff. The new CNC machined enclosure, no lean, either anodized black or silver, or unfinished, which can be powder coated any other color. The new Breakout board makes the wiring, the whole thing, quite a bit easier. New enclosure has a recessed 510. Get up to a 30 mil atomizer on there without overhang. So thanks for watching, everyone, and we'll catch you next time.